The rain has been falling for 3 hours. Not the gray drizzle that makes you check your phone. Real rain. The kind that turns the ground into a mirror and makes rivers out of things that weren't rivers an hour ago. You're standing at the edge of a dry canyon in what will one day be the Sahara, roughly 10,000 years ago. The sky upstream is black, and somewhere in that blackness, a wall of water is moving toward you at 25 miles per hour, carrying boulders, uprooted trees, the accumulated force of an entire watershed, emptying at once. You have no weather app, no satellite alert, no road sign warning you to turn around. You have only your senses, your group, and whatever your ancestors had figured out before you. So how did ancient humans survive something they couldn't even see coming? The answer turns out to be stranger and older and far more sophisticated than anyone expected. Right now, you probably avoid flash floods by watching a notification pop up on your screen. A NOAA system catches the pressure drop, models the rainfall, and vibrates your phone before the water has even left the mountains. Ancient humans had none of that, and yet the archaeological record shows they lived for hundreds of thousands of years in some of the most flood-prone environments on Earth. Steep-walled gorges in North Africa, narrow river valleys in the Levant, carved desert canyons in southern Arabia, and kept surviving. Somehow, so how did they do it? The first answer is carved into the landscape itself. In 2014, researchers excavating the Wadi Sura region of southwestern Egypt, a desert canyon system that was once a lush, populated wetland, found repeated layers of human occupation sitting consistently on elevated terraces, always at least 8 to 12 meters above the ancient floodplain. The camps weren't scattered. They weren't random. The same elevated ledges were reused across multiple generations, sometimes thousands of years apart. Archaeologist Savino de Lernia and colleagues, working with the Archaeological project, documented this pattern across more than 40 sites in the Fezzan region of Libya. The physical evidence told a precise story. These people didn't camp wherever was convenient. They camped wherever was safe, and they passed that knowledge down so reliably that their children's children were sleeping on the same ledge, for the same reason centuries later. This wasn't instinct. This was institutional memory encoded into the land itself. Here's where it gets strange. Everyone assumes ancient humans survived floods by running, a panicked sprint uphill at the last second. The evidence suggests the opposite. The survival strategy wasn't reactive at all. It was almost entirely predictive, and the tool they used to predict wasn't anything physical. In 2018, anthropologist David Turton at Oxford University published a synthesis of flood response behavior in traditional pastoral societies across sub-Saharan Africa and the Horn of Africa, drawing on decades of fieldwork. His analysis found that groups with the lowest flood mortality didn't respond faster than other groups. They moved earlier, sometimes 12 to 24 hours before any visible sign of flooding, based on reading a specific cluster of environmental indicators. Cloud formations upstream. The behavior of grazing animals, which abandon low ground before humans perceive any change in the sky. The smell of wet soil arriving on wind from a direction that had been dry for weeks. And crucially, the sound of distant thunder reverberating off canyon walls in a pattern that indicated rainfall not directly overhead, but many miles upstream in the headwaters. A group that had lived in a canyon long enough to know that a particular echo meant danger somewhere it couldn't see. That group survived. Groups that had just arrived did not. The time advantage of reading those signs correctly was, on average, 6 to 18 hours. Enough to move an entire camp, the elderly, the children, the food stores, to high ground, calmly, not in a sprint. But there's a problem. Individual observation alone doesn't explain the full picture. One person reading thunder echoes could be wrong. One person watching the birds could miss the moment. So what actually made the difference between a group that made it and one that didn't? The answer isn't a technique, it's a structure. In 2009, evolutionary anthropologist Kim Sterelny at Australian National University in Canberra published research arguing that human survival across hostile environments depended on what he called scaffolded learning, the deliberate, multi-generational transmission of environmental knowledge through apprenticeship and structured practice, not just through imitation. His work drew on evidence from Paleolithic tool use patterns, but the principle extends directly to terrain and hazard knowledge. A child raised in a canyon didn't just watch an elder read the sky. They were walked, repeatedly, through specific locations, taught specific landmarks, told specific stories about what happened when those landmarks looked a certain way. By the time that child was an adult, the knowledge wasn't memorized. It was embodied, automatic, the kind of knowledge that bypasses the slow deliberation of conscious thought and activates before you've decided to act. That's the mechanism. It explains the reused ledges in the Fezzan, It explains the 12-hour warning window. It explains why traditional communities that maintained this kind of knowledge transfer showed dramatically lower flood mortality than communities that had been disrupted by colonization, by forced resettlement, by the breakdown of intergenerational contact, even when the disrupted communities had access to modern warning systems. Modern technology is faster. It is not always deeper. So what about when prediction failed? Everyone assumes that when an ancient human was caught in a flash flood, it was a death sentence. The physiological data says otherwise. Research by wilderness survival physicians, including a 2005 study led by Dr. Gordon Giesbrecht at the University of Manitoba, confirmed that adult humans maintain functional swimming capacity for significantly longer in turbulent water than the 90-second figure commonly cited for cold water immersion, particularly when water temperature is above 15 C, which characterizes most of the flash floods in the subtropical regions ancient humans occupied. The critical variable wasn't swimming ability. It was decision-making, specifically fighting the current laterally rather than against it, and identifying debris, a large floating log, a root structure, as a temporary flotation aid within the first 60 seconds of submersion. Evidence that ancient humans understood this principle comes not from texts, they had none, but from the physical profile of human hands. A 2020 study published in the Journal of Human Evolution, led by Katarina Harvati at the University of Tübingen, analyzed grip strength and hand morphology in archaic Homo sapiens remains and found consistent evidence of the kind of sustained power grip associated with climbing and clinging, not just tool use. The hands of early modern humans were biomechanically built for exactly the kind of rapid vertical scramble and grip and hold behavior